Thanks to our speakers, Hayley, Richard, Shu, Harshit, and Margot. We're now going to open on the 50-minute Q&A. We'll go through as many questions submitted as possible. Keep the questions coming. So I'm going to direct the first question to Margot. You mentioned that the novel properties that Service Router, one of the novel properties of Service Router is that it's client library embedded into the application, which is more efficient. However, as a library, there is loss of control of deployment of new code once it becomes a library. How does that affect what techniques you use to control and combat the downsides of that?
Yeah, that's a great question. So historically, Service Router actually had a big problem with this. Being a library that's embedded in client code and having no control over the deployment of your code makes it really hard to roll out new features and to fix bugs and to deprecate old features. So there's actually two things that have happened in the last 5 to 6 years that have made this much easier. And the first was mentioned in the talk. It's this dynamic configuration. So a lot of the rollouts that we do and a lot of the features that we roll out are gated by kill switches backed by dynamic configuration. So what that means is that we have more control over the rollout of these features. It's somewhat orthogonal to the actual binary push. So that's one part. And then the second part is, though, you still need to actually roll out the code that has that gating in it in order to be able to use that gating. And historically, I think lots of services wouldn't push for potentially months at a time. So you're essentially having to wait 6 months to a year or more to support backwards compatibility on deprecated features. But a somewhat recent effort called Push for Push, it's basically a company-wide effort that encourages all services at the company to have binaries that are running code that's newer than 60 days old. So if a service is starting to become stale, essentially, and run code that is quite old, they'll actually be alerted. The service owner will be alerted to update their binary, and what that does is it keeps all of the code across the company fresh, so that client libraries like ours have less of a problem of having to kind of maintain that backwards compatibility.
Thank you. So I'll switch over to asking this question to Richard from James. How does Flux handle a capacity planning scenario when the downstream dependency follows a nonlinear model or a different model than the current system?
So this is definitely one of the bigger challenges when trying to do demand modeling in our system, is that a lot of these requests have non-homogeneous request costs. And the primary metric that we use for demand modeling is QPS, which can lead to skewed results when we say this product. A good example is an ads load in the US costs very different than an ads load in the EU. One way we try to combat this is by also doing demand modeling using CPU instructions, but we only do this for a small subset of our services today where the CPU profiling is accurate enough where we can accurately say that this is real demand and these percentages are better than what we're getting from QPS. And then Hayley can add a little bit more about what we do in the solver side to account for this kind of gap in capacity versus demand.
Yeah, so within the solver, so we have this residual variable that accounts for all the regional differences. Since the global attribution is assuming the ratio is consistent across all regions. So this accounts for some of the non-linearities, but then also additionally, after we produce this capacity plan, it's then ingested by a capacity estimator to override some of these estimates. So given the traffic distribution, some services might have slightly non-linear models and this can be developed using either load testing, queue analysis, or some simulation. And so this is how we are updating the estimates. And in general, the linear model is usually a rough upper bound. And so these overrides don't have any issues with executability.
Thank you. This one I'm going to direct to Shu. Why didn't you directly develop Solar as the UDP-based network stack for the first generation as you were kind of evolving your architecture?
Okay. Solar outperforms Luna mainly in two aspects. First, the Solar is datagram-based and can be delivered out of order, which gets rid of reordering buffer and is friendly to hardware overload. But back to 2017, we had no idea what is bare metal and the performance of software-based Luna was just good enough for the 50 gigabit per second network cards at that time. Second, every Solar connection contains 4 subflows with different physical network paths so that it can recover from network failure in milliseconds. But back to the first evolution in cloud storage, we care most about average performance. With large deployment of Luna in production, we found it really challenging to reach the SLA of tail latency with TCP, since network jitter or failure happens quite commonly. Moreover, we were asked to deliver a solution at scale in less than 10 months. So implementing TCP and existing protocol saved us lots of time in design and emulation. That's why we didn't design and develop a completely new protocol like Solar from the very beginning.
Thank you. I'm going to direct the next question to Harshit. Does Service Router support multiple data plane, including sidecar and in-process library, or is it only process? Is it in process only? This from Lei.
Right. Yeah, Service Router definitely supports multiple data plane flavors, both sidecar and in-process libraries supported. As I mentioned in the talk, sidecar is not as common as in-process library. That is just for the efficiency reasons that we want to go as much as we can with the in-process library. The challenge with library is that it cannot, you'll have to implement it in multiple languages. So the way we solve that is implementing it just in C++ and having a wrapper, which is a sidecar for other languages like Python and Java. There is another like similar flavor for Service Router, which is where it is hosted as a remote service, and a client library or sidecar talks to this remote service. And this is also somewhat popular because it reduces the fan-in into the backend service. So those are the 3 primary flavors of data plane that we have in Service Router.
Just to kind of double click on that, since I'm interested in this a little bit. Have you explored the possibility of actually doing generation of like various codes from a base kind of language, or is that not something that the team hasn't explored?
The generation, can you repeat that last part again?
Code generation, like for different languages as they come along from a base, yeah.
Yeah, we definitely have that. Like we have code gen for other languages, but these are still wrappers. And then we have to kind of maintain the binding between different languages. That is what our sidecar is. It's a lightweight process that just binds to the C++ core library. So one of the advantages there is like most of our important routing related features stay within our single programming language, and others are just binding to those features through the sidecar.
Cool. Next question, this is for Hayley from James. Have you done or considered doing the following: ingesting artificial load into the product's environment to test against existing capacity or capacity forecasting?
Yeah, so as I answered before, in the capacity estimator, some of these models are based on load testing. So a service can go in and artificial or like manually override this model. And then this model is used as an override for the capacity planning solver.
Next question is for Margot from Prakash. Does Service Router also handle requests to database and caches like Memcache? How does it handle when data is sharded across nodes?
Yeah, so that's a good question. There's 2 parts here. So one, yes, Service Router does handle requests specifically to Memcache and other major caching services at Meta. This is actually a recent development. Historically, major caching services that are super latency sensitive, like Memcache and Tau, were running on their own routing stack that was hyper optimized for that specific use case. And historically, Service Router was actually built to serve the masses, you could say, like the tail end of microservices, the tens of thousands that are running at the company. And it was more of a feature-rich routing library than the one that supported these caching services, but at the cost of efficiency, which is why those caching services couldn't use Service Router as well. And about 2 or 3 years ago, we embarked on a journey to actually overhaul the performance of Service Router to meet the needs of these very high performance, low latency services like Memcache and Tau. And I think as of today, both Memcache and Tau are running on Service Router, as well as many other caching services. So that's the first part of the question. And then to answer the second part, I think the question was like, how does Service Router handle sharded services? It's a good question as well. We have first-class support for sharding in Service Router, and it's done through being able to configure your shard map. And the shard map that we provide is application agnostic, meaning Service Router doesn't need to be aware of your specific application logic to be able to route to your different shards. And many services at Facebook actually use a product called Shard Manager, which I think was discussed in a previous edition of At Scale in 2022 or 2021. I would actually say the majority of traffic running through Service Router uses Shard Manager, which handles sharding on the service's behalf and feeds the shard map into the Service Router library so that Service Router can route appropriately.
Thank you. And the next question I'll direct towards Harshit. Often the microservices consist of machines with varying levels of compute power. How does the load balancing account for differences in machine compute power?
Yeah, so this is a great question. Like we have been constantly trying to improve our load balancing. And this is where we also use control plane to aid our client local decisions. So control plane maintains the information about compute power of each host. And then client performs the weighted selection based on the different weights of the host. So if a host is twice as powerful, it is twice as much likely to receive the request from the client. And in this, the hardware awareness, we can also tune these settings based on the user inputs as well. So where if they want to balance based on some other characteristics of the host, there are provisions to support that as well.
Thank you. I think we can sneak in maybe a couple more questions. So next question would should go to Shu. What are the pros and cons of RDMA per your experience so far?
Okay, that's a very good question. Hello? Can you hear me?
Yeah, I think we're struggling a little bit. So why don't we go to the next question? Again, Harshit, I'm going to call on you. How does cross-region load balancing interact with the power of two-choice load balancing?
So yeah, one of the philosophy that we went with is to keep as much decision local on the client as we can. One of the exception to that was this picking a right region where we use the cross-region load balancer. So the way currently it works is that there is a two-step process. First, we pick a region. That hint comes from the central coordination to all the clients. It comes in the form of routing tables. Based on that hint, client then within a region picks the optimal host based on its own power of two load balancing. So in this manner, we are able to kind of work with the central system while making sure that clients are making their own optimal load balancing decisions. One interesting point here is that the central decisions only happen every 60 seconds. So client should be resilient to the stale information on which region to go to. And there are various techniques that clients deploy to make sure that the error rate stays low, including fault tolerance related techniques.
Thank you. So I think that concludes our Q&A session. Stay tuned for closing remarks, and thank you all.